In section 3.2, we talk about the slope of a line. So the slope of a straight line containing the points x1, y1, and x2, y2 is slope equals m equals y2 minus y1 over x2 minus x1. This is the rise over the run, and that's when x1 does not equal x2, because then we would get 0 in the denominator, which we can't have. So let's go ahead and find the slope passing through the point -2, -3, and 1, -4. So I usually just label mine in order of x1, y1, and x2, y2, but it does not matter the order as long as you keep the order the same on the top and the bottom. So I'm just going to label this as x1, y1, and this is x2, y2. So we get m equals y2 minus y1 over x2 minus x1. Well, y2 is -4 and y1 is -3 all over x2 is 1 and x1 is -2. And so on the top we have that double negative going on. So this is really -4 plus 3 all over. We have a double negative again, so this becomes 1 plus 2. And so -4 plus 3 is -1, and then 1 plus 2 is 3. So my slope is -1/3. And so lines sloping upward to the right have positive slope. So if the slope is positive, things are looking up. And if lines are sloping downward to the right, they have negative slope. So if the slope is negative, then things are looking down. The slope of a horizontal line is 0, and the slope of a vertical line is undefined. So let's go ahead and find the slope of the line passing through the point 1.6, 2.3, and -6.4, 1.8. So again, I just like to label mine in order, but it doesn't matter. We've got x1, y1, and x2, y2. And so plugging into our slope formula, y2 minus y1 over x2 minus x1. We have y2, which is 1.8, minus y1, which is 2.3, all over x2, which is -6.4, minus x1, which is 1.6. And so on the top, we end up with -0.5. And on the bottom, we end up with -8. And so when I divide this out on my calculator, I end up with 0.0625. What about the slope between 5/3, -1/2, and 2/3, -1/4? So again, we're just going to plug it back into our formula. We've got x1, y1, and x2, y2. So we get m equals y2 is negative 1/4 minus y1, which is negative 1/2, and this is all over x2, which is 2/3, minus x1, which is 5/3. And so on the top we have a double negative, but we're also going to need a common denominator so we can combine these together. So we have negative 1/4, and this is going to become plus 1/2. But to combine these together, we need a common denominator. So I am going to multiply the 2 by 2 to make it 4. And what I do on the bottom, I have to do on the top. Now in the denominator, we already have common denominators of 3. So we can just go ahead and combine the numerators. 2 minus 5 is negative 3, all over 3. And so back in the numerator, we have negative 1/4 plus 2/4. And the denominator, which is negative 3 over 3, is going to simplify nicely to just negative 1. And so when I combine the tops together, I end up with 1/4 all over negative 1. But when I divide by a negative, it just changes the sign of the top. So we've got negative 1/4. Now let's go ahead and talk about parallel and perpendicular lines. So parallel lines are two different lines with the same exact slope. So M1 would be equal to M2. Perpendicular lines are two different lines with slopes M1 and M2, and they're perpendicular if M1 is equal to negative 1 over M2. And so these are just opposite reciprocals. Opposite means that the signs change. So if one is positive, the other one is negative, or vice versa. And reciprocal just means that I flip the number. So or flip the fraction. So we want to find the slope of a line that is parallel to the line L that passes through the points negative 6, negative 7, and negative 1, negative 9. So what we need to do is we need to find the slope of the original line. And so we're just going to label our points. We've got x1, y1, and x2, y2. And then figure out what the parallel slope would be. And so y2 is negative 9 minus y1, which is negative 7. And then on the bottom we've got x2, which is negative 1, minus x1, which is negative 6. And so we end up having double negatives on the top and the bottom. And so we just want to simplify that. We end up with negative 9 plus 7 all over negative 1 plus 6. Well, negative 9 plus 7 is negative 2. and -1 plus 6 is 5. And so parallel lines have the exact same slope. And so we usually indicate this with 2 vertical lines to say it's parallel. And they have the exact same slope, so that means that they are both -2/5. Now what about perpendicular? We still want to approach this the same way, but it will change when we find the perpendicular slope. So the first thing we have to do is we need to find the slope of the original line. So plugging into our slope formula, we have y2, which is -5, minus y1, which is -6. And then we've got x2, which is -3, minus x1, which is 4. And so on the top, we have double negatives. We've got -5 plus 6. And on the bottom, we just have -3 minus 4. Well, -5 plus 6 is going to give me 1. And -3 minus 4 is -7. And so I'm just going to rewrite this as -1 over 7. And so to find the perpendicular, we write this little upside down t. We change it from negative to positive to find the opposite. And then we flip the fraction. So this is going to become a positive. And then flipping it, we get 7 over 1, which we can just write as 7.